Okay, students, today we're going to talk about a word that you've run across maybe a time or two, and I haven't officially given you the definition of it, but you've been working with some polygons. Now, the mathematical definition of a polygon is a closed shape with 3 or more sides. So we have 3 sides, 4 sides, 5 sides, any number of sides. And of course, if it has 3 sides, it's going to have 3 angles. So 3 or more sides and angles. Now, the word that would probably bother you here is the word closed. So let me just show you the difference between closed and open. This is a closed shape, commonly known as a triangle. This is not closed. So this right here is not closed. That means all the sides have to come together to make a closed space in here. Okay? So this is called open, and this one is closed. So this is a polygon. This is not a polygon. Okay? Now, let's talk about the ones that we have already investigated somewhat. Does this have 3 or more sides? Yes, it has 3, and it also has 3 angles. This is one shape of a triangle. Here's another one, has 3 sides, has 3 angles, 3 sides, so it fits this definition. Does this have 3 or more sides? Well, yes, it has 4. So all of these right here on this side are called quadrilaterals, but they're also called polygons. All of these are called polygons. Now, these have a specific name. They're called triangles. These 4 can be put into a subgroup called quadrilaterals, and then there's some specific names for each quadrilateral. Trapezoid, rhombus, rectangle, 1, 2, 3, 4, 5, pentagon. Okay? Now, I put a couple of examples of not polygons. But before we leave this, I want to circle all of these. These are all polygons. They're not the only ones because there's a lot more, but these are all polygons. But right down here, these are not polygons. So what can you tell me is the difference between these two shapes and these shapes? Well, I know you've all said, although I can't hear you, you've all said these have straight sides. So we need to add something to our definition right here. A closed shape, because these were closed, these circles, the circle and this oval was closed also. So it's a closed shape with 3 or more sides and angles and straight sides. 3 or more straight sides and angles. So we could have inserted that word right there in front of sides and took care of that. But you have to know the difference between what's a polygon, because all of these plus a lot more are polygons. Anything round is not considered a polygon. And the prefix poly means many. This part of the word means many. So that's why it has to have 3 or more sides to be called a polygon. The gon part just means a side. So this means many sides. Okay, now get your papers out. We're going to need pages 419 through 423 for today. Alright, and as you can see in the Solve and Discuss, Gabrielle wants to cover the floors. Cover means area, right? Remember, we're doing area. She wants to cover the floors of a room and a hallway in her dollhouse. She measured the room and the hallway and sketched the floor plan below. So we don't even have to look at the house anymore. We're just looking right here. Here's our information. And so it says, how much felt does she need to cover that floor? Well, we are going to take this odd shape and we're going to decompose. That's a good word. It says, how can you decompose or split up this shape into shapes that you know how to work with? Well, we can either put a line right across here and figure that little rectangle in this big one, or we can bring the line down here and do this long skinny rectangle in this one. I choose to put it right here. Now then, do I have the measurements that I need to find the area of this rectangle? Well, I've got this one, but I don't have this one. So what is this length all the way from here to here? Well, this is horizontal because it runs this direction, and then here is a horizontal, and here's another horizontal. So if I take these two horizontal pieces and add them together, it should be this whole length. Well, 5 and 15 is 20, so that should be a 20. Okay, so now I have a base times a height for this rectangle. Do I have this one? Well, this is 5, but I need this length. Let's see. Well, this whole length is 22, so this one, this is vertical, so these two vertical pieces should add together to give me that one. So if I have the whole thing and one of the others, I can subtract, so 22 minus 10 makes this piece right here be 12. Now then, I have a base and a height of this one. I have a base and a height. Remember, bases and heights have to be at 90 degrees to each other. Remember that? Okay, so now then, we're going to find the area of that blue thing that she sketched out. The area total is going to be the area of the big rectangle plus the area of the smaller rectangle. So we've got a base times a height plus a base times a height. Well, the big one right down here is 20 times 10. And the little one is a 5 times 12. Now the hardest part of this was finding the missing links. Once you have that done, then it should be a piece of cake after that. 20 times 10 is 200. 2 times 1 is 2 and put 2 zeros on it. 5 times 12 is 60. Should know your multiplication facts. And you add those together and you get 260, and that would be square inches. Inches squared. Now, if you can't do with that in your head, then you pick up your calculator and you use it to do that. Now then, we will get the same answer if we had drawn our line down this way and figured this long skinny rectangle and this little squatty rectangle. You still get the same answer. Now, there's one more way to come up with the very same answer. We did that by decomposing it and adding two pieces together. There's another way to find the area, and it's by subtraction. So I'm going to take this whole outside piece and I'm going to just finish it out and make me one big giant rectangle. And do you agree that if I find the area, base times height, of this whole thing, and I subtract off that piece, it's going to leave me the leftover. So I'm going to find the area total by finding the area of the great big one and subtracting off the area of that one small one. And again, I got to have the right numbers. So I have a whole length here. I need to know this whole length here. Well, I know it's 15 to here, and it's 5, so this was a 20. So I'm going to figure the 22 by 20, and that gets me this whole area extended out. So that's 20 times 22. Then I want to subtract off this little thing this rectangle I've X'd. Well, it's a 15 by what? If this is 22 and it's 10, this was my 12 right there. So if I take off this 15 by 12, then that leaves me this odd-shaped blue L-shaped piece. So you tell me, what is 20 times 22? 2 times 22 is 44, and put a 0 on it. And then what is 15 times 12? And it's 180. And if you take the 440 and you subtract 180, again, you get 260 inches squared. The same thing we got when we did it up here by adding. So it works that way also. I think that's pretty cool. All right, turn your paper over to page 420. This one's worked out for you, so we're just going to talk through it right quick. Denise is building a patio in her backyard. It looks like that shape, which is a hexagon, by the way. 1, 2, 3, 4, 5, 6. 6 sides is a hexagon. She needs to know the area before she orders the patio tiles. What's the area of the patio? So we want to know the area of this hexagon. Well, notice that she has split the hexagon into 2 triangles that are the same size and 1 rectangle. So she's going to explain herself down here. Decompose the polygon into rectangle and 2 identical triangles. Each triangle is 1/2 the base times the height, same formula that you have learned. And the base is 6 and the height is 2. Okay? So each triangle is 6. Okay? And we've got 2 of those, and that's why there's 2 6s right here. The rectangle is a 4 by 6. Length times width, or base times height. I wish they'd use the B and the H. 6 times 4 is 24. So we got 6 plus 24 equals 36. And she found the area. Now, let's see another way over here to do this. We're going to decompose and recompose. So she took these 2 pieces off right here and cut them apart. And she fit one of them. That made this be a straight side, which is here. She took one of these triangles and put it here, and the other one and put it here. See the 2 greens? Which made a square, because this is 6, and now this was 4, and 2 makes 6. 6 times 6 is 36, and so there you have it, and you got the same answer doing it that way. So you can decompose, you can recompose. Decompose and recompose means to put back together. Okay, try it. Shari found the area of the patio by composing the shapes as shown at the right. How is Shari's strategy different? Well, this is the same problem. She put these 2 together to make a rectangle. She put these 2 together to make a rectangle, and then she had the rectangle in the middle. So she has 3 rectangles, a 2 by 3, a 4 by 6, and a 2 by 3. Okay? Please go to page 421. Example 2. The Robinsons are planning to resurface the path that surrounds their garden as shown. What's the area of the path? So we just want to know the path, the brown path. So the area of the path can be found by subtracting the area of the garden from the total area of the garden and the path. I say that's the easiest way. If you split this up into rectangles, you're going to have a rectangle here, and here, and here. You're going to have 4 things to add up. If you go find the area of the whole thing and subtract off that one rectangle in the middle, then it will be about half the work. Okay? So we're going to find the total area of the garden, which was the 8 by 7. That's this number. Find the area of the garden. Oh, this was the garden and the path. We're going to take off the garden, which was a 4 by 3. And then we're going to subtract them. And subtraction is much easier on this problem than doing it the other way. And I don't know if you figured this out or not, but good mathematicians seriously will look for the easiest way to do it, because there'll be less steps to go through and less chances for mistakes. Now, easy doesn't just mean pick up the calculator. Easy means thinking through it and what's the best, most efficient way to work the problem. All right, let's go to example 3. Find the area of the polygon. Let's see what they did here. Well, because this one corner is chopped off, they decided to make that a triangle. So I've got a rectangle here, and I got a rectangle here, and I got a triangle here. So here's the right triangle, 1/2 base times the height, a base times the height, the base times the height, and they added it all together. Now, could they have done this with subtraction? Of course they could. They could have extended this on out to here, and this is 11 this way, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9 this way. They could have done 11 times 9 and found this whole thing and then subtracted off that corner right there and done it by subtraction also. Okay, let's look at the triad. Ooh, this looks like a fun one. Okay, remember this is a parallelogram, so the easiest way to do this one again is by subtraction. To find this blue area, we're going to find the whole big blue thing, and we're going to subtract off the little white parallelogram in the middle. Well, remember that our formula for finding the area of a parallelogram is the same as a rectangle. It's a base times a height. Okay? Well, if I call this the base, 1, 2, 3, 4, 5, this is a 5, I got to go find the height that's perpendicular to that. So I have to extend some sides. My height is 1, 2, 3, 4. Okay? So to find the area of this whole thing, the white piece included, it's going to be 4 times 5, which is 9. Now then, I'm going to go subtract off the little white one. Well, it's a 1, 2. It's 2 that way, and it is 2 that way. So the area of the little one is base times height also, which is a 2 times 2, which is a 4. So to get the area of the blue, it's going to be 9, and it just says square units. 9 minus 4, which is 5 units squared. And there's your answer. You have to know your formula. You have to know how to find the base and the height. All right, turn the page. 422. Here's your summary. We can either decompose or recompose. We can decompose it into shapes and add them together, or we can increase the size and do it by subtraction by taking a piece off. Okay, let's go to the do you understand. How can you find the areas of polygons? We are going to split the shape into shapes we know the formulas for. Then use addition and / or subtraction. Okay, number 2, describe a way in which you can use subtraction to find the area of the shape in exercise 4. Let me go back and find exercise 4. Oh, It's right here. Sorry. Exercise 4. They're talking about this one. I'm sorry. So we can extend the outside boundary line, and we're going to draw a picture, little easy picture. We're going to extend that, and then we're going to subtract that rectangle off. To find a larger area, comma, then subtract the small rectangle. Extend the outside, so we're going to make this look like a rectangle instead of an L or whatever it looks like. And then we're going to subtract off the piece that doesn't count. Number 3, describe how to break the floor plan in example 3 into a trapezoid and a rectangle. Use coordinates to describe the line you would draw. Okay, let's go back to example 3. That's this one right here. Okay? They want it to be a trapezoid and a rectangle. Well, the easiest way would be to put a line right here. So this makes a trapezoid on this side of the slash line, and this makes a rectangle on this side. So they want me to explain how to do that. So this is at 9, 2, the ordered pair 9, 2. So we want to go to 9, 2, and we want to put a slashed line all the way up to 9, 11. Okay? 9, 2 to 9, 11. So draw a line from 9, 2 to 9, 11. This will make a rectangle to the left and a trapezoid to the right. I think this is fun stuff. Love this stuff. Hope you do too. Number 4. Find the area of the polygon. We've already talked about one way we could do this, so let's do it like the way we talked about in problem number 2. Let's extend this on out. We'll do just what we said, and then we're going to subtract off that rectangle. So this is a 10 by 20. So we're going to find the area of, I'll call it the shaded, by finding 10 times 20 and subtracting off. I need to know what that length is right there. Well, that's a 10. Subtract off 6, that makes that be a 4. I'm using only horizontal lengths to get that. So I have a 4 by, I need this length, this is 20. Subtract off 8, that leaves this to be a 12, 4 by 12. Base times height, base times height. 10 times 20 is 200. 4 times 12 is 48. What is 200 minus 48? 152. Our units are inches. That is inches squared. Anytime you find area, your units are in square units. Okay. Number 5. Notice we haven't learned any new formulas today. We're using old formulas, triangles, rectangles, parallelograms, things that we've already learned. Nothing really new today. It's just how we're putting it together. A polygon with vertices at 6, 2. Vertices are the corners. So go find it. 6, 2 is right there. 9, 5. We go right or left, then we go up or down. 9, 5 is right there. 12, 2. 12, 2. 12, negative 4. 12 to the right and negative 4 down. And 6, negative 4. Okay. So, when they give you points like this, they gave them to you in some order, either clockwise order or counterclockwise order. So we went from here to here, from here, let's see, let me back up. We went from here to here to here to here to here. So they're going in clockwise order. So we want to do the same thing. We want to connect them in the same order. We went from this one to this one, and you should be using a ruler. From this one to this one. Math is very logical. This one to this one. Oh, it's going to look like a little house. This one to this one. And this one back to where we started. And that's how you do that. You don't skip around and cross them over and do it. You go in some pattern, either clockwise or counterclockwise. Now, what do they want us to do here? Well, our instructions up here above number 4 said find the area. Oh, so I need to find the area of this now that I'm done. And I'm going to choose to find the area of a triangle and a rectangle or square, whichever one it is. So my area of my triangle is going to be 1/2 BH. I'm going to do it right over here. Base is 1, 2, 3, 4, 5, 6. This is a 6 across here. So I have 1/2 times 6, and it's 1, 2, 3 high. Okay, half of 6 is 3. 3 times 3 is 9. So that's 9. It doesn't say, so we'll just put units squared. Now let's do the rectangle or square. Let's see what it is. Well, this should be 6. 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, 5, 6. So it is a square. So the area of the rectangle or the square is 6 times 6, base times height, which is 36 units squared. Now, I'm going to have to add these to get the total. So my area total is going to be 36 plus 9. What is 36 plus 9? 9 and 6 is 15, so that's going to be 45 units squared. Okay, start with your formulas, figure out, decompose it into something you know, then write your formulas down, do each piece, add them together. If you use subtraction, show me that you're going to subtract them. This one was easier this way. And we've got the graph, we can just count to find out how long each piece is. Remember to count spaces, don't count lines. Okay? All right, let's look and see what you're going to practice today. Practicing problem solving. Oh, I like number 6. That would be easiest by subtraction. Put a little line across here, do the whole thing, and subtract off that little piece. I do use subtraction on this one too. I would extend those 2 corners out, do the whole thing, and subtract those 2 little pieces off. I'm going to let you figure out how to do the rest of them. You got problems 6 through 12 on your practice and problem solving. You also have access to a vocabulary page and some other things whatever your teacher wants to do and thinks you need practice on. There's a vocabulary page. You probably should be working on your vocabulary even if I'm not working on it with you. Please, please, please work on your vocabulary. Remember what a polygon is. Polygons, closed shape with 3 or more straight sides and angles. Okay? Those are all polygons. Not named specifically. We could name them. Those are polygons. Those are not polygons. Remember that. If it's got a round piece on it, it is not a polygon. Okay, and there's your lesson for today. Get busy with your practice and problem solving, and I'll see you next time.